So my wife comes to me and says, I'm finding all these recipes online and they're amazing. One thing though, they have a ton of ads, and a lot of times there's this really long emotional blog and the recipe's buried at the very bottom of the page. So three things are true. My wife is frustrated, I love her, and I know how to code. I turn on my computer and build my own recipe app, one that is for our family that does not have any ads or any of those blogs that we don't want to read. And things work. A week later, I have a API that is putting out our favorite recipes, and we like it. As I build more features though, suddenly those things that I made in the application are no longer working. And that's when I realize a hard and uncomfortable truth. I need software tests. Don't be like me. Choose the better path. Build software tests from day one. I'll show you how you can get started. Software tests are frankly boring. It's a lot more fun to build new features than it is to make sure that those features work as expected every single time you make a change to your application. But like working out and like brushing your teeth, you just need to do it to make sure that you have a healthy, functioning application. A software test is just a check to make sure that a certain piece of your app is working as you expect. And if you make enough of these tests, you can string together a safety net where you can then confidently integrate new features and make sure that the things that you already built are still working as expected, assuming you wrote good tests. My application is in FastAPI, and today I'll show you how you can test a FastAPI app using Pytest. Let's head on over to the laptop. All right, here we are at the laptop. We're here to do two things. First, we'll set up the API so we can look at what the application is, and then we'll spend most of our time looking at how we can test the API. I'm here at the KP Data Dev repo, and today we'll focus on the Pytest Your FastAPI app. In that folder, you'll find a README explaining what the application is and how you can get it up and running yourself. On a high level, the application is right now just an API provided by FastAPI, the famous Python package. And FastAPI is basically providing an interface to interact with our recipe data that sits in a database provided by SQLite. FastAPI to engage with the database to interact with the recipe data, we're using SQL Alchemy as our ORM. So let's get this up and running. You can clone the Git repo and follow the instructions in the setup. I have already cloned the repo and I have all the code right here, open in VS Code. The first step, of course, is to set up your Python environment. If you follow these instructions, you can set up a Python virtual environment and load or install all the packages needed for this project. I've already done that in my terminal on the left, so I'll move on to the next step. Well, once you've got the code and once you have your Python environment, the next thing you need is some recipe data. If you follow the instructions here, you'll find a script that basically initializes a SQLite database and loads it with some sample recipe data. So let's do that together. I'm here in the folder for this project, Pytest Your FastAPI app. If we move into our scripts folder, you'll see that there's a file called cdb.py. And so we'll just execute that file. And what this will do is create a database called recipe.db that wasn't there before. It is here now. And it will create tables within that database and load some sample recipes into the database as well. All right, so then we have our code for FastAPI and SQL Alchemy, and we have a production database in SQLite. The only thing left to do is to start our API. Let's copy this command and paste it into our terminal in the root project. What this will do is start up a UVcorn worker to supply or serve the FastAPI application. You can see now this is saying that our UVcorn worker is running on this local host on port 8001. Let's go to that. If you go to the same URL and go to the docs URL, you'll find a very helpful Swagger UI that summarizes the different API endpoints that we have. So we can see that we have a group of endpoints for engaging with recipes, and then we have another group of endpoints for handling units, things like teaspoons or cups, or what you might find commonly in a recipe. If you look deeper, you'll see that we can do things like read recipes, create new ones, get a single recipe, update recipes, or if you're done with a recipe, just outright delete it. What Swagger is really good for is engaging with our API directly within this UI. Let me show you what I mean. Let's say that we wanted to get a list of all the recipes that we have. Well, if we wanted to just test it out, we can click the try it out button for this endpoint. And once we press execute, the Swagger UI will automatically set up the curl command to call that API endpoint and then present the results right here below. We made this get call to this endpoint, and we have now a list of recipes. Banana bread, black bean enchiladas, all the good stuff. Let's say that we wanted to look at just one recipe. Well, we can go to the endpoint for recipes by ID, type in a certain ID that we're interested in, and hit execute. And once we do that, we'll then get our delicious chana masala with a list of instructions and ingredients needed to make it. That's a little bit of what the API is. It's a way of engaging with the database of recipe data that we have. And right now it's an API. One day it should have a UI in front of it to make it a little bit more user-friendly. If you're curious about the code that supports all this, you can go to the repo, and all of the code is within the API file itself. You'll find that our routers for each of these endpoints are in the recipes and units modules respectively. And then there are a few other files for setting up our API configuration and database connection to SQLite. We could spend a lot of time just on the API, but this is not a video of how FastAPI works. This is a video of how we can test our FastAPI application. So let's focus on that. What is a test? Well, in the same API folder, we have a subfolder of tests. Let's just check one of those tests out. Let's look at our test recipes module. There's a lot here, and we'll go through it in time, but let's just look at one sample test to begin with. If we scroll through here, you'll see a few functions, and this is a pretty good function to examine slowly. Here we have a function called test read recipe by ID not found. Let's check out what it's doing. Here we have some kind of test client, and we're executing a get function to this endpoint, recipes ID 999. And then when we have the response, we're performing a few assertions. We're asserting that the response has a status code of 404, and that the detail within the response says something like recipe 999 not found. And that's all a test really is. A test is executing some kind of scenario and then verifying that the result or the response is what you might expect. In particular, this one is just checking to make sure that our API is user-friendly. If we, again, go back to our recipes by ID endpoint, previously we typed in 1 and we just wanted to get recipe number 1. We should expect, if we put in a crazy number like 999, we should get some kind of helpful error message like this recipe does not exist. And that's what the API does. We get a 404 message saying that, hey, this recipe isn't found, please try again. And this test just verifies that that's true, that continues to happen through the lifespan of the application as we add more features and as we change things to it. So then the question is, how do we run a test? Well, if we go back to our terminal, I'll shut down our API and clear our terminal. To run a test, it's as simple as typing the command Pytest. What this will do behind the scenes is search our folder for test modules and test functions, and then execute them and give you the results of whether the test passed or failed. Here we can see that the module found 21 items or 21 tests. Each of these dots represents a different test, and the fact that it's green means that the test passed. We could get more information by passing in the flag -v, and that stands for verbose. All that does is give you a little bit more information about the results. In this case, we can see that we have all of our tests listed by name, and instead of dots for the pass-fail, we get the explicit word passed in a handy green color. Just to show you what might happen if a test failed, let's suppose that we are one day changing things in our API and we just happen to break something. Let's say that in our API, we have a URL that creates a new unit. And what this logic does is verify that the existing database doesn't have a record with that unit as well. Well, we would expect to return some kind of 409 error for a conflict. Let's just suppose that one day we broke that by returning a 200 error saying everything is good. Well, if that happened and we reran our tests, we would be notified that, hey, something in your application is not working as expected. We can see here that one of our tests fails, particularly the tests that make sure that we're not creating duplicate units. In the output, we can also see exactly where that broke down. Here we can see that we were supposed to get a status code of 409 when we attempted to create a unit that already existed in the database. And in this case, we got a 200, which is not the 409 that we expected. And so this is an error message that comes with Pytest out of the box. It makes it really easy to confidently make changes to your API, knowing that if you wrote good tests, you can make changes without breaking your existing functionality. Let's change this before I forget back to what we want and rerun the test to make sure that our code works as expected. All right, so all 21 tests are passing now. All right, so we've looked at how we can run tests. Let's dig a bit deeper into how a test works. In our test folder, you'll find that there are some test modules that begin with the prefix test underscore, and this is a Pytest thing. When we run the Pytest command, the way it figures out what test to run is by searching your directory for any files that begin with test underscore. And within each of those modules, it also looks for functions that begin with the name test underscore. And so that's basically all Pytest does. It goes through your directory, looks for those prefixes, and then generates a list of tests to run, and then executes those tests. One important file to know about within Pytest is our conf test. This is a file that can house any kind of objects or configuration that you want to be used across all of your tests. You'll notice here that we have set up 3 different test modules: test main, test recipes, and test units. And that's just to keep things organized so that we don't have one giant file of tests. If you do want to reuse something across these tests, you can use you can define that object in the conf test, and that will be made available here. Let's look into conf test and see what's in here. You'll notice that the first thing we have in conf test after our import statements and a little bit of setup is a fixture. Fixtures are basically what set the stage for your tests to run. It's a way to ensure that you have a consistent environment for each of your tests. For this fixture, what we're doing is overriding our database. And it's worth stopping here to make sure that we perform best practices when we're testing. Let's go back to our architecture graphic. In this application, we have an API that's running in FastAPI, and it's engaging with some SQLite database called recipe.db. And in particular, what I'm going to call out is a production database. You might have a test that simulates the creation of a recipe, and you might call that something like my test recipe, but you don't want that to appear in your production database for your end user to see. It will look a little unclean. When performing tests then, it's really important that you have a test database, kind of like a sandbox where you can perform all your tests without disrupting the performance or the quality of your production database. And that's what this fixture is doing. It's ensuring that when we run these tests, we are not attempting to create or delete recipes in our production database. Essentially, all it does is it creates a database and creates the tables and data needed within that database. And then it effectively hijacks the FastAPI application to make sure that the FastAPI application is not pointing to the production database. Within the FastAPI application, if you're familiar with it, there is something called a dependency injection. And this application uses a database connection as a dependency injection. It's a lot of words. Basically, what that means is our FastAPI application has a consistent database connection used across all of the endpoints. We're just trying to modify that FastAPI application temporarily so that it points to our test database. So that's what we have here. We're overriding our dependency so that we are now using a test session instead of our production session. And then we are yielding control to whatever test function is relying on this fixture. Another fixture that we have is our test client. This is like the bot or the pretend user that is interacting with the API while these tests are performed. And if you go to some of our test functions, you'll notice that test client is needed in each of those functions. So let's go back and check that out. If we go to our test recipes and scroll back to the top and just check out some of these functions, you'll notice that, for example, the function test read recipes has a input of test client, and this is the client that ultimately makes the HTTP calls to the API endpoints. All right, so that's a little bit about fixtures. Fixtures, again, just set the stage and allow you to have a consistent environment for all of your tests. In this context, we're using fixtures to have a test database set up provided by TestDB, and also to have a test client set up that actually interacts with our API. One other use of fixtures is reusing sample data. In our test recipes, you'll notice that we have a fixture for our sample recipe with an ID of 1, with a name of John Masala, and an activity flag of true. And what this basically returns is a dictionary with those key value pairs. So if we scroll down and look at where this sample recipe is used, here's one example where we're testing how a recipe is read by ID. We passed the sample recipe fixture into this test function, and then later on it's used to verify that this test is working as expected. Let's just check this out. So what's this test doing? This test is taking the test client and it's making a get call to the recipe endpoint with a certain ID. Then it's interpreting the response as a JSON object, converting that into a Python dictionary. And then the assertions are these. We want to make sure that the response has a status code of 200, that the ID, name, slug, and activity flag are what we expect them to be, and also that certain keys are present in our JSON object. If we wanted to, we could write this information of the sample recipe right here within the function itself. Let's see. We could right here say that our sample recipe is this dictionary item, and just remove this fixture from our Python function signature. And that would work just fine. This would still work as expected. But suppose that we wanted to use this recipe over and over again in different tests, like the one right below it. Well, then we'd have to repeat this for each one of the tests. And so that's one of the advantages of using fixtures. We basically take commonly used sample data, make it a fixture, and then reference that fixture within each of our tests so we don't repeat ourselves. All right, if you made it this far, thanks. And I have a treat for you. Just figured this out recently. We talked about how you can run tests in the terminal, but VS Code has an interactive way of working with your tests right from VS Code. So let me undo all this and save. In VS Code, if we go over to our side panel, there is a section for testing. And this basically allows you to run your tests within VS Code itself. We'll configure Python tests, and out of the box, it'll set up a testing environment using either unit test or the Pytest framework. We're using Pytest. And all you need to do is to pass the directory where your tests reside. In this case, our tests are in the API folder, specifically the test subfolder within API. Behind the scenes, VS Code will do some thinking. It'll generate some configuration files, and eventually we'll see our tests represented in this UI here. And that's pretty cool. If we wanted to run our tests, we could come up here and press the play button, and we'll get our output from our test in this panel below, as well as the results of our tests in this UI to the right. Pretty cool. This is really handy. I think it's cool because you can make changes to your code within VS Code, the editor, and as you're making your changes, as you're developing, you can run to our test panel to make sure that your changes didn't break anything. Again, for example, if we are modifying something and we happen to change the way that our recipe creation endpoint is working, let's say that we're looking for redundant recipes, we might expect a conflict of 409, but if we accidentally change this to be a 200, we could do that and rerun our test to verify if everything is working as expected or not. And hopefully we have a test here that makes sure that we get the proper response. Okay, good. We have a test here called test create recipe conflict, and that test failed because we can see that, again, we turned a 200 instead of a 409. So anyway, I think that's cool. Hopefully that helps you. All right, well, that is pretty much it. If you want to check out the code, feel free to do so and use it to your heart's content. You can go through the code and see some of the tests that have been made. If you go to the outline and just minimize everything, you'll see that we have several tests for reading recipes, creating them, updating them, and deleting them, making sure that our endpoint is doing just what we expect. And likewise, we have a similar series of tests for our units. All right, hope this has been helpful. If you like what you see, please like and subscribe. If you have any questions, drop them in the comments below. I'm happy to get back to you. And until next time, keep coding.